This lesson is going to be about ionic nomenclature. In other words, we're going to be talking about how to name ionic compounds. Ionic compounds are one of the most common types of compounds that we see in chemistry, and they are commonly called salts. So, table salt would be a common example of something that's ionic. Typically, when you see an ionic compound, it's going to be a white powder, or you could also see it as a colored powder or possibly a larger crystal. In an ionic compound, you have ions that stick together to make neutral compounds. So ions, as we would have talked about earlier, are charged particles. One of the charges is going to be positive, the other charge will be negative. When you take a positive and a negative and you put them together, they attract and you have the charges cancel out. So in the most common example that you would think of, sodium chloride or table salt, sodium cations and chloride anions stack together and they make a cube. NaCl, one sodium, one chlorine, is called a formula unit for sodium chloride because that's the simplest ratio that we can have. So in this example up here, you can see that we have a chloride ion, we have a sodium ion, and they sit next to each other so that all the negatives are attracting positives and vice versa, and we end up with this large cube that repeats. So let's say that we want to recognize a compound as being ionic. Well, the easiest way to do that is going to be to look for positive and negative ions. If the compound is ionic, it's always going to have a cation, or a positive charge, and an anion, or a negative charge. So if we just have single elements, we're going to end up with a metal and a nonmetal. The reason for that is that metals want to lose electrons and become positive, and nonmetals want to gain electrons to become negative. So, if you put a metal and a nonmetal together, you end up with a positive and negative charge, and you get your ionic compound. However, we don't always have to have just elements. We can have a group of elements together, all carrying a charge, and that thing would be called a polyatomic ion. So, a polyatomic ion is just going to be like a normal ion, but there's a few atoms all together that we treat as one unit. So some common polyatomic ions are going to be on the back of most periodic tables. Down here at the bottom, we have some examples of different ionic compounds. Some of these are going to be just elements. So for instance, lithium chloride here just has a metal, lithium, and a nonmetal, chlorine. The two of those together go together and make one ionic compound. We can also throw a polyatomic ion in there in place of one or the other. So down here, this NO3 is all one polyatomic ion. So that entire thing is going to be our negative charge, and this magnesium here by itself is going to be our positive charge. So we still end up with a positive and a negative, it's just that our negative is a little bit. Okay, so to review what we've talked about so far with ionic compounds, they form when atoms transfer electrons. So atoms transfer electrons so that they can have a complete outer shell. So down here, we have a sodium, its valence electron, there's just one of them, wants to go away. Chlorine has 7 valence electrons, so it wants one more to fill in and get to 8. So what's going to happen is chlorine is going to steal sodium's electron. So this is going to get stolen and go over here, so that now our sodium has lost a charge, a negative charge, so it becomes positive. And chlorine has gained a negative charge, so it becomes negative. Now we have something positive, something negative, and the two will attract. Like we mentioned earlier, we get a repeating stack of these things all going together that gives us a crystal lattice type structure, And that formula we get that repeats over and over again, that sodium and that chlorine make a formula unit. An ionic compound with just elements will contain a metal and a nonmetal. Sometimes we can put a metalloid in there, but you're not going to see that as often. So, as a refresher, everything over here is a metal, and everything over here is a nonmetal. We can, however, substitute either our metal or our nonmetal for a polyatomic ion. So now that we can recognize ionic compounds and we're familiar with what makes them up, we can finally get to how to name them. So there's a basic three-step process that we can use to name an ionic compound. The first step is going to be to determine our formula if we don't have it. So as a refresher, if we have two elements, let's say sodium and chlorine, on the periodic table we can look up and see that sodium is likely to have a positive charge and chlorine is likely to have a -1 charge. So to get our subscripts, we would crisscross them. So the +1 goes down here, becomes a 1. This one goes down there and becomes a 1. But since 1s are implied in a normal formula, we can just drop them and we end up with NaCl. Once we have our formula, we can name our cation and then name our anion. So to name a cation, it's just the name of what it is. So the name of sodium is just sodium. To name an anion, we change our ending to "ide." So what was chlorine becomes chloride. So the final step then is just to put our names together. So in this case, we have sodium chloride. Remember that ionic names do not tell you how many atoms you have. So in this case, we just had 1s here, so it didn't actually matter. But if we had, for instance, magnesium chloride, the formula for that has a 2 in it, but that does not change how we name it. The name is strictly based off of the cation. Let's look at some examples. In our first example here, we have strontium and oxygen. Strontium, if you look up on the periodic table, will have a +2 charge. Oxygen will have a -2 charge. So when we crisscross those, we end up with Sr2O2. However, for a formula unit, we want to have the simplest ratio. 2 is not the simplest ratio we can have, so we can reduce both of those and get 1. So we end up with SRO. Once we have our formula, we just have to name our cation, name our anion. So strontium stays strontium. Oxygen, because it's negative, becomes oxide. So we name this strontium oxide. In our second example, we have sodium there with its +1, oxygen with its -2, so our formula becomes Na2O. To name this, we just name our cation, so sodium, and our anion, again oxygen becomes oxide, so we end up with sodium oxide. I will let you try the third one here on your own. So to use a polyatomic ion, we treat it the exact same as we would have with our other ones, except you have to know the name of the polyatomic ion. So here's an example list of polyatomic ions that we can look at over here on the right. So all you have to do is look for one of these, and if you see it, name it like you see it. Let's look at some examples that have polyatomic ions. So in our first one we have here, there is strontium, and there is a group of stuff all together. So that group there is all going to be a polyatomic ion. So if you look on the back of a periodic table, you'll find the list of polyatomic ions that are common to come across, and you'll find that this thing is called dichromate. So before we can name it, let's put this together because we have our two things here that we need to put together to make our compound. So to do that, we're going to look up that strontium has a +2 charge. Since our polyatomic ion, dichromate, also has a -2 charge, those are going to cancel out. So our formula is just going to be SrCr2O7. Now to name it, all we have to do is name the cation, strontium, and name the anion, dichromate. So earlier when we had anions that were nonmetals, we had to change the ending to "ide". Do not change the ending to "ide" if it is a polyatomic ion. So we don't have to say dichromide or anything like that. That would be a different polyatomic ion. If it's a nonmetal, change the ending. If it's a polyatomic ion, just write exactly what the name is. So again, the name for this is just strontium dichromate. Now, in our second example here, we already have our compound put together. So all we have to do is name it. So our first element is rubidium. That's going to be our cation. Our anion, you'll have to look on the list of common polyatomic ions, is going to be sulfate. So all we have to do is just put those things together, rubidium sulfate, and we have it named. And finally, our third example is going to be the exact same thing. We just name our cation, cesium, name our anion. You'll find that Cn together is going to be cyanide, so we end up with cesium cyanide. The tricky thing with these to remember is that you cannot name each element in there. You have to look for polyatomic ions, and if you see something that is on the polyatomic, our last consideration for naming ionic compounds is when they contain a transition metal. So if you remember, a transition metal is any of the elements that are in the middle of our periodic table. So any of these purple elements here would be considered a transition metal. So transition metals can have more than one possible charge. Our first row here was always +1. Our second row is always +2. But anything in this area can have more than one possible charge on it. So when we name our ionic compound, we have to say which charge it actually has. So we do that with Roman numerals. So let's say that we had iron with a +2 charge on it. That would be iron 2 oxide. All we have to do is write in here this parenthesis Roman numeral 2. The corresponding formula for that is FeO, remembering that if this is a +2, this is a -2, they cancel out. But if our formula was Fe2O3, now in order to get that Roman numeral, this is no longer equal. We actually had a +3 charge on here. So to indicate that +3 charge, we have to put in our Roman numeral as it is over here. So the actual name for this compound is iron 3 oxide, and the name for this compound is iron 2 oxide. Remember that when you say the name, the 2 or the 3 indicates the charge on the cation. It does not indicate how many of that atom you have. That's probably the most common thing that students will mistake when they go to actually name these. So with that, continue to practice these.